I am Alina Brad, a senior scientist at the Department of Political Science at the University of Vienna. I study international climate policy and the politics of sustainability transformation. In this video, I'll be discussing the politics of net zero and how carbon dioxide removal technologies may overturn climate policy. We'll look at the potential of these technologies to change the way we think about and act upon climate change mitigation. In this video, you will get to know what net zero and residual emissions mean. You'll learn about carbon dioxide removal technologies and understand how these technologies may affect our efforts to reduce greenhouse gas emissions and address climate change. By the end, you will have a clear understanding of the political aspects of net zero and why some argue that these targets may delay rather than boost climate action. You've probably heard the term net zero or climate neutrality in the news a lot lately. It has become a key focus in climate discussions, influencing long-term strategies of both governments and businesses in their efforts to combat climate change. But what does it actually mean? Net zero refers to the balance between the greenhouse gases we emit into the atmosphere and the amount of carbon we can absorb from it, as outlined in the Paris Climate Agreement. While most activities can be fully decarbonized, some emissions will be difficult or even impossible to completely eliminate. This means there will be residual emissions. Residual emissions are the greenhouse gases that remain after when net zero targets are achieved. For example, sectors like agriculture and shipping are expected to continue to emit substantial amounts of greenhouse gases. This is mostly attributed to technological limits. But think about it. It also involves crucial social and political questions that will shape future sustainability transformation. How many residual emissions from, say, meat consumption are we ready to afford? And does this mean we have to radically reduce other emission-intensive activities like flying? What are the trade-offs and how can we ensure that decisions are made democratically and outcomes are just locally, nationally, and globally? These questions also relate to carbon dioxide removal, the counterpart of residual emissions. To achieve net zero targets, we need to balance residual emissions with techniques that actively remove carbon dioxide from the atmosphere. In other words, any greenhouse gases we emit must be offset by an equal amount being removed. Carbon dioxide removal can take various forms, including natural processes like ocean, trees, and soil, as well as engineered methods like direct air capture blocks. One widely used technology in climate models is bioenergy with carbon capture and storage, which not only produces energy, but also removes CO2 from the atmosphere. Despite its prominence in climate scenarios, many of these engineered removal methods are still in the early stages, with only a few demonstration sites currently operational. The prospect of deploying engineered removal methods has raised serious sustainability concerns. But it also involves specific political risks. A key issue we need to consider is the danger of climate action being delayed or undermined. What if the expected use of removal technologies leads to reduced efforts to cut emissions? What if people or businesses think that such carbon removal can easily compensate for ongoing emissions, lowering the sense of urgency to cut emissions? What if they are used as an excuse for not embarking on the profound sustainability transformation that is required? To deal with these risks, we need to give clear priority to reducing emissions over deploying carbon removal technologies in climate policy design. We need separate targets for emission reduction and carbon removal to make sure that carbon removal complements rather than undermines other mitigation efforts. And we need to rethink the issue of residual emissions as a social and political question at the heart of the global climate justice and the just sustainability transformation.